Okay, here we go. 4, 1.
What?
Day 2.
Kelly is putting that in my head. Kelly, you were not a lady.
Okay, yesterday we put a multiplier in front of sine and cosine. Today we're going to put a multiplier in front of the angle and see what happens. So we're going to go with y equals sine of a b times the x. So we're going to see what multiplying the angle by a number does to the original graph. So this is just our calculator stuff where we kind of just check it out. So let's get the window set up for sine x, and let's just see one cycle of sine. So if I want to see one cycle of sine, what should I change my window? So that because normally the window is from, it's showing us the 2 full cycles.
What's one cycle? Is that without anything in the front?
Right.
Okay.
So where does sine start and where does it complete?
Wait.
Yeah.
Do you want us to put the other parentheses?
It doesn't need to be there. Nope. If you don't put one on the end, the program automatically puts one on the end.
Oh.
Okay. So the window. Sine starts on 0.
You're right.
Just like the clock. Guys. Yeah. Guys in the back. Enough.
Why is it always us? These guys never stop talking.
I'm talking about from Katie to Lexi to Kenley to Alexis to Axel, that whole group of 6. When I say in the back.
Like right there.
God, Alyssa.
That group of 6 is in the back.
I don't like the term guys because you just
Oh.
us, but yeah.
Annoying students in the back.
Wait, this is all on tape now.
Oh yeah. That's who I'm talking
My
to.
name just got thrown under the bus.
Yes, it did.
Reporting.
Yeah. Be careful who you associate yourself with. Life lessons.
You have to add info.
Yeah, according
Yep.
to my
Life lessons. Okay. Back to this. Sine starts at 0. Where does it finish itself before it starts repeating again? Just like the clock. How many radians? 2 pi. So your max, I want you to put 2 pi. And I don't care what that x scale is at. That doesn't matter.
Why is it max?
Mine automatically changes when I move it.
Okay?
Why is it max? Why doesn't
This is the part of the x-axis it's showing me from 0 to 2 pi. That's all I want to see. That's why I'm calling it. It's not going to show me any more than that. Okay. And then the mins will just go -4 to 4, and it's maybe set up like that already because of the window from yesterday.
How come mine says shade RES?
I don't know why that is. It's newer operating
How did
system.
you get 1.57?
It just automatically was there.
Oh, I got just 1.
That's fine. And now graph. You should see one cycle of sine. Does it look familiar?
Wait. Can you go back to your window thing? I'm confused.
Oh, because you were talking and weren't with me when I started?
Why does mine say shade RES?
I told you I don't know.
That's what's confusing.
Well, don't worry about the shade, res, blah, de blah. My res is 1. Yours is something else. Okay, everybody have a graph of sine?
Yep.
Okay, go back to the y equals. Let's put a multiplier of 2 on the x. So let's go sine of 2x. And see what that affects.
Whoa.
Do we
I don't like that.
Graph?
Yeah.
I don't like this.
Okay,
Why?
what did that do?
Just divided it by 2, made it smaller by half.
Made it small. Made what smaller?
The length, the x.
The wah.
Oh shit.
It squished it together. It made it the amount of radians it takes to complete. It shortened it up. How many cycles of sine are there now in this same window?
2.
There's 2 of them instead of 1 of them. So it's shortened up the amount of radians it takes to complete. We call that the period. So the normal period is from 0 to 2 pi, but this one shortened it up. So where is it completing at, do you think? 0 to pi, and then there's another one from pi to 2 pi. So if we go back to y equals, if I put in let's just keep redoing this one, a 3, what do you think we're going to see?
Multiple.
How many of them do you think we're going to see?
3 of them?
3, because it's going to cut it by down to 1/3 of what it normally is.
Yeah, I don't like this.
Okay.
Seems like a lot of
So we should see 3 of them if we discovered the pattern. There's 1, 2, 3.
So then,
Oh, so they kind of count the hump.
I'm kind of counting. An up and a down is 1, 2, 3.
okay.
That's a cycle of sine. When it goes up, goes down, and comes back. Okay?
Where does it end? If,
It goes on forever.
no, I mean, if, the one, like the 2x that ended at, instead of
Pi.
so where?
We'd have to take 2 pi and divide that by 3. And we're going to do those
Because
fractions.
there's 3 of them?
3 of them.
Okay.
Okay? What if I multiply by, say, like a half, a fraction? What should that do?
I feel like
Should
that
make it
makes
twice
bigger.
as big.
It should make it, stretch it out, make it take longer to complete.
Yep,
How much of it are we going to see, do you think?
half of it.
Oh, wow, yes.
Wait, so it's not going to be pushed?
Nope, it's going to stretch it out. I'm actually only seeing half of it. I'm seeing that first hump.
Does it take 4 pi?
Yes, it's going to take 4 pi to complete it, twice as long to complete it. Okay, so
You're asking something?
I think we discovered what the B does for us.
I don't understand but can we do a negative?
Nope, we're not doing negatives.
For,
We'll never multiply the angle by a negative.
okay.
Okay, go back to your original graph. We put that amplitude definition on there. Now we're talking about the period length, how long it takes to complete itself. So from the start to the finish this way is period. And the normal period length is 2 pi, unless we change it like we just did. And same thing for cosine. The period goes from 0 to 2 pi.
I done our very first one.
Yep.
Yes, my favorite song.
So, for us to figure out what the period is, we've got to work with that B. So, back to our Explore, what we just discovered is that B
Bless you.
affects the period. B affects the period. And the way it affects the period, there's a little formula. 2 pi divided by the B equals the period. 2 pi divided by the B value will equal the period, how many radians it takes to finish itself. Alright, so now,
Do we always need to be in radian mode?
yes. We could do it in degrees, but they don't do any of this. Alright, so let's do 2 of these. We'll do a sine and a cosine.
Wait, can you explain
That's just the formula you're going to use to figure out what the period is. If you have a B number here,
this? And the period is,
from start to finish, how many radians that takes. Okay, so let's do one. Let's do that 3 you were asking about. Let's do y equals sine of 3x. We need to keep track of 2 things when we make our tables. The amplitude, which tells us our high and low, and now the period, if there's a change there. So what is the amplitude of this graph from yesterday?
1.
1. How do you know it's 1?
Because there's no number. in
The
front of it.
multiplier out in front. And the period is no longer 2 pi. So the formula I just gave you to figure out, if I start at 0, where's it going to finish? I have to do 2 pi divide by the B number. What is my B number?
3.
2 pi over 3, so 2/3 pi. So we're going to get into some ugly fractions in this chapter.
Great. You can't just do the decimal?
No. No decimals.
Mine doesn't go in the...
Okay, so we're ready to make our 2 tables.
wait,
Yes?
can you just tell me the definition of period again?
Period is the amount of radians it takes to complete itself. Usually for a couple days, yeah, they laugh about it, make fun of it, then we move on. You got to give them some time.
Yeah.
So, the definition for period is the number of radians.
Because when I said period, and then you guys started like,
Maybe that was right. That's a funny building joke.
To so it's just the number of radians it takes to complete the full graph of sine, and cosine, which starts here, go through those 5 key values. Okay, so the fractions will get a little more challenging for you today. You're going to want to either have a calculator in your hand to do the fractions or do the math by hand. I don't care, but you're going to want to know how to do fractions here. All right, are you ready? Because this is the challenging part.
Did you say we're not going to be able to use a calculator for this one?
Parts of the stuff you will not be using your calculator. So we still have 5 key values. Where is sine and cosine? Where is it always starting? Which x value is 0. Normally it would finish at 2 pi, but because I have this multiplier of 3 in here, it shortened up that period. Where is it going to finish? At 2 pi over 3. It's going to finish at this period length, 2 pi over 3. Now I want my 3 values in the middle evenly spaced.
So would the last one always be with the period?
Today.
Oh, okay. Oh, again.
Because we are going to shift this thing over, back and forth, where we're not starting at 0. Then that won't be the case.
Oh, boy. Okay.
Yeah, that's another day though. So yesterday we did the stretching, up and down. Today we're going to do the squeezing in and stretching out this way. Then we'll have to shift the whole thing up and down, and then we got to shift left and right. Those are the only 4 things we can do. What?
Why is there just sine and cosine and no tan?
Oh, we'll get to them after. We spend all kinds of time on sine and cosine, but because secant and cosecant are directly related because they're reciprocals, those are super easy. And then we spend a day on tangent and cotangent. So we go really slow through all this stuff, and then we go rocket speed after that. So anyway, I want to find the middle. So I want to average 0. Forget about the pi. What's the average of 0 and 2/3? What's halfway between 0 and 2/3?
2, 6.
4/3.
Don't hurt me. 1/3?
yeah, it's 1/3.
It's 1/3. Okay, if you need to do this on a calculator, what you're doing is averaging 0 plus 2/3 divide by 2, because that's how you average 2 numbers together.
Math book. So the middle one is pi over 3?
The middle one would be pi over 3.
Oh, I can tell you what the other one is.
Okay, now we're going to average these two, because I want to be in the middle of these 2 numbers. So I want to average 0 and 1/3.
Pi over 6.
I was going to say that. Raise your hand.
Oh, really? Well, how come it came out of my mouth? How come you put 1/3 instead of pi over 3?
I don't care about the pi, it's a 1/3. I'm just going to stick a pi on this answer.
Oh, okay.
Yeah, it just makes it life easier if you just kind of ignore the pi and see that as 1/3. You want to average 0 and 1/3. Now, are you just writing these down, or do you actually know where people are getting these from? I can quit. I can show you on the calculator what you're supposed to be doing. 0 plus 1/3, divide by 2, math frac. 1/6. So pi over 6. And then this last one is the average of 1/3 and 2/3.
And now I got pi over 2.
Yep, 1/3 plus 2/3 is 1. Half of 1 is 0.5, so pi over 2. No decimals, all fractions. What don't you get, Michaela? You can do it on a calculator. You don't have to see them in your head. We're just averaging. Grab your calculator. I want you to do it before we move on so you feel comfortable. Do 1/3 plus 2. Do you know where I'm getting the 1/3 plus 2/3 from?
Yeah.
Okay, so grab your calculator.
Looking at it from here.
Yep. So just use a calculator to do these. Because 1/3 plus 2/3 actually equaled 3/3, which was 1,
So you
cut in half.
You did the 1/3, the 0 plus 1/3, because
I was finding this one. It's in the middle of these 2. So I averaged the 2 around them. So these 2 get averaged to get this one.
okay.
Okay. All right. now we need our sine pattern. What's my sine pattern?
Well, it's just like regular, isn't it?
Yep, it's regular, so what's my pattern?
So we got our standard 0.
Give me the words.
Oh, it's oh shoot.
Axis,
Max,
max, axis,
minimum,
min, and axis. And where are all of my axis values at?
0.
0. What do I use to figure out my max and min?
Well, it's just be the one.
Amplitude.
The amplitude. So 1 and -1.
Not so bad, not so bad.
That's not so bad. Just the fractions, and that's just averaging fractions. And the calculator will do all that for you. But you don't need a calculator if you can flip and multiply in your head and all that good stuff. Okay? How difficult are the x's to do on the second table? What did you learn yesterday about the x's?
Change it to negative.
Just change them all to the opposite of what they were. So we don't have to do any averaging anymore. We're just going to take the opposites. Okay, now the y values on sine. Axis values are always the same, so I got 0, 0, 0. And then what did you learn about the y values on sine yesterday?
Still flip.
They switch around. I don't start with the max here, it's the min, and then the max. Okay, I know all of my x's are evenly spaced. These graphs are going to end up looking the same because yesterday when we made these, this was our first one, I said the first tick mark was going to be pi over 2, then pi. Those are all a half apart. Well, today, they're all going to be a 1/6 apart. This is pi over 6. This is actually 2 pi over 6, but it's pi over 3. Do you agree that 2 6 is 1/3? Then this next one would be 3 6, pi over 2. And then 2 pi over 3. Because we average, the space between all of these is the same. And I'm going to 1 and -1. And then my nice smooth curves. And then I go into the backwards ones. Negative pi over 6. I don't have to write every one of these in here either. Just the end one is all I really need. And I went down here, 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 and here. Good to go with that one?
It's a lot of work for one problem.
Aw, that's too bad.
No sympathy.
None.
I know.
None. Everybody done? I like to see the heads down and you're just working. You're not really copying. You're actually doing them. That's awesome.
Can you chill for 2 seconds? For real.
Chill. How do I chill?
Just don't do anything. How do you do it? So chill. It's just gonna take about the same amount of time.
Mm-hmm. They're all about the same. All right, I'm going to go with cosine. 2/3 x. Yep, that's after this. I've got like 2 more after this and we're going to be good for the day. Okay, so just do one thing at a time, then we're going to put the 2 together after this one. All right, pick out your amplitude and your period before you get started. The amplitude is just 1.
Is it always just
Nope,
Amplitude is whatever the number before the cosine.
right here. So
Oh,
1,
okay.
yep. Period. We've got to do a little bit of work to figure it out because I've got a b number here that's 2/3. So the formula is take 2 pi, divide by your b. Okay, how do I have a fraction within my fraction. How do I make the top a fraction? Put it over 1. How do I divide by this 2/3?
Multiply by what?
So that would be 3/2. What am I going to get? 3 pi. So I've stretched it out a little bit. 2's will cancel. I get 3 pi. So it's going to complete itself out at 3 pi instead of at 2 pi. You good with that? Ready to make our first table? 5 key values. Starting at 0, where are we going to finish? 3 pi. Okay, which one should I find?
The middle one.
The middle. You average 0 and 3. So let's just add the two numbers together, divide by 2. And there it is. 0 plus 3 is 3. 3 over 2 is 3 over 2. So 3 pi over 2. Now I want to average here. 0 plus 3/2. Divide by 2. 0 plus 3/2. Divide by 2. Yep. Because think about it. If you make this a fraction, you can do this in your head. Because after you add, how do you divide by 2? What should you multiply by? 1/2. 3 over 2 times 1 over 2 is 3 over 4. So 3 pi over 4. And then I'm going to average 3/2 and 3. So that's 3/2 plus, if I do a common denominator here, that's going to be 6/2. Are you okay with that? I'm going to divide by 2. Or pick up a calculator and do these. This is the part where you need to figure out a way you can get these and not just copy them down.
Are we allowed to use the calculator?
Yes, you're allowed to use the calculator to figure this stuff out,
Even on the test?
even on the test. The first page of the test is a matching that you don't get to use a calculator on at all. But then the rest of the test is just tables and graphs. And all the points are picking out the 4 things. We only have 2 right now, but we will have 4. And then making the tables, and we're looking for the points, and then the sketches afterwards. So what did you guys get? 9 pi over 4. And now we've got the cosine pattern. Where does cosine start? Cosine starts? Yep, it's the cereal bowl. So it starts at the top of the cereal bowl, then comes down, finishes at the top of the cereal bowl. So it's a max. Then what? Axis. Min. Ax max. I want to commit those to memory. So where's my max at? 1. Axis is 0. Negative 1. 0. 1. Second table should not be too challenging anymore.
Okay, for cosine, if there's not a negative a, don't all the y's stay the same?
The y's are going to stay the same regardless if it's negative or positive. So the x's are going to switch. And cosine does have that vertical line of symmetry, so no matter what, it's always going to match, so the y's stay exactly the same.
Even if there's a negative?
Yep.
I feel like yesterday that wasn't the case.
No, it's fine.
No matter what.
Because the other one's going to be negative also.
At the end, you put a negative at the
Oh, duh. I did.
No matter what.
No matter what, cosine y's are going to stay the same because they're symmetric. You can fold it, and they have to match up, so all the y's have to be in the same position.
Quick question.
Yep. This time I'm not going to write all of them in. My last one's going to be 3 pi. They are all a 3/4 pi apart.
So sine Y's do switch.
Yes. Because that doesn't have a line of symmetry. So cosine is starting high. And then we work our way down. And we get a nice little bowl shape. And then the second one looks exactly like that.
Is it gonna connect?
Yep, because they share this point. We start our table with that shared value.
When x is 0, oh, I flipped. Why aren't you flipping the bottom row?
Because cosine doesn't switch. Remember, cosine folds and matches. I could fold this over, and this red one will be right on top of the blue one.
Shoot.
The y's on cosine stay the same. The y's on sine switch.
I just failed the whole first one.
Yeah, you did.
Seems like you either get an A or an
Yep. Most people manage to get the A.
Well, you haven't met me.
Oh, I have confidence. Okay, are we ready to put the two things together?
No, wait.
Okay. I'm going to do one more, and I think it'll be fine.
Yeah, chill for a second.
Wait,
No chill zone. No chill.
Yeah, never try that.
She's not gonna understand that.
Are we good? Am I done chilling?
Oh, yeah.
Okay. This is it, last one today. Put the two things together. Do you want a sine or a cosine? Let's do a sine.
Sine.
Let's go y equals, let's go -1/2 sine of, that was 2/3, let's go 3/4 x. Let's make it all challenging. Throw a lot of fractions in. See how you do.
Blue. Awesome.
Okay. Before we start anything, pick out amplitude and period.
Okay, amplitude is never negative.
Correct.
Oh, shoot.
Kenley, failed again.
Oh, thanks.
Amplitude's a half, but what does that negative tell us to do? That we're going to remember, we're going to flip. That means our max and mins are going to switch.
Would that be the case in a cosine problem?
What's that?
Would that be the case in a cosine problem too?
Yep, same thing.
See, I told you. You said those never change.
The y values, once you make your first table, I'm saying it never changes when you go to the second table.
Oh.
That's what I meant. Okay. Period is 2 pi divided by what? 3/4. So I will make that 2 pi over 1 and multiply by 4 over 3. Oh, this is a nice fraction. What do we get? 8 pi over 3.
Why do you have to do that to
So we lengthened it out a little bit. That's over 2 pi. Stretched it out just a hair. All right, here we go.
I'm sorry, guys.
Jenny, I think you need to go home.
All right, where are we starting this table at?
Yeah.
0. What's my last x value where it's going to complete?
8 pi over 3.
8 pi over 3. You want to try those middle values on your own? Try the 3 middle values on your own, see what you come up with.
God.
Do them on your own.
4 pi, oh.
Everybody wants to try them.
I just got excited.
Yeah.
I get it. Ooh. She's covering up. Ah. I didn't. Is it
a monkey.
2 pi? Is it just 2 pi, the 6th variable?
Oh, yeah, it is.
You're welcome.
Thank you. 2 pi.
So if the, finger dinger, the color, the red one, the
Yeah.
guy, if that top number is even, then you just always cut it in half.
Cut the top in half.
Why is it?
It reduces down to 2 pi. I had 6 pi over 3, thinking I was all smart.
Oh,
Ha.
that's fine. But keep
But who knew 6 divided by 3 came out 2 if you didn't look at it and think about it? Me.
So now for the y's, can we multiply our standard, operating procedure, can we multiply that by 2?
No. Okay, let's do sines pattern first. We've got x, normal sine, x, max, x, min, x. Because it's not normal, because it's flipped, what do I do?
Multiply it by 2?
X min, X.
Switch, min,
Oh, shoot.
flip, max. Flip these over. Axis stays an axis. Where is my axis? 0. 0. 0. Where's my min? Negative 1/2.
Would it just be negative 2?
It is negative 1/2. Amplitude is a half.
Why you said flip it over? I thought that was 2.
No, flip the graph over, not the number over.
A.
Flip the graph over.
Kinley.
Okay?
Freaking
Okay. Once you get, all the work is in the first table, really. The second table is just remember the little tricks to make it a shortcut. What's the trick through my x's? Well, not quite the same.
Negative.
They're almost the same.
Yeah,
Axis values always stay the same no matter whether you're doing sine or cosine, so those 3 spots are done. And then what about sine? Do they have the same y values or opposite y values? Opposite. No line of symmetry.
I feel like I get it. There's just a lot of little things you guys
Mhm.
are gonna forget. Yeah. And then
We'll do enough of them. It's not difficult. The fractions are the hardest part, the adding and dividing by 2.
No.
And then we're going up to a half. All right, where's that worksheet at? Okay, we're just going to do these problems, so I'm going to switch them out.
You did that.
What did I do wrong? Oh, I did do it wrong. Oh, I'm still wrong.
Okay, what did you do wrong?
I didn't go down. It was supposed to go down. I just automatically went up. I didn't go down.
Man.
Sorry.
Well, that's why you don't copy her.
Yes.
I wasn't copying her. I thought it was the same answer. Darn you to heck.
Yeah, don't copy. Because I've been thinking about the assignment. I don't want to waste this. Let's see. We're just going to change some of the equations on this here graph, this worksheet you had yesterday. This here worksheet. So take out that there worksheet you have.
Wait, okay, can you go back to the graph?
Well, don't even look at mine. If you can make sense of that, you're better than I am. Yeah, look at Matt. Matt did it right. He caught my mistake.
Let me see. Yeah, Matt's always right.
What can I say?
We're going to leave 2 alone. Okay, number 3, we're going to put an amplitude in front here. Let's go with a 2 sine 2/3 x. Throw a 2 up in front. And then let's do a negative
Wait. What was the top one?
2. Put a 2 multiplier in the A spot. And then let's go with a negative, what sounds good?
1.
Not negative 1.
Negative 2.
Negative 3. Stick a negative 3 in there. Cosine 3x.
So we're doing both pages?
Yep, both pages today.
That's a lot of homework.
Y equals negative 3 cosine 3x. And y equals 2 sine 2/3 x.
Oh, yeah.
I did not change anything on 2. I just left that one.
So we're doing number
Do number 2, 3, and 4.